Hello and welcome to the presentation where I shall talk about blue block light solutions tailored for psychiatric hospitals. We will also dive into a case study from Østmarka Psychiatric Hospital in Trondheim in Norway. My name is Anders Bru and I'm Concept Manager for Human Centric Lighting in Glamox. First, I want to say a few words about Glamox for those of you who don't know who we are. Glamox is a global company with long traditions that operates in more than 60 countries and have 10 factories around the world. Glamox produces state-of-the-art LED technology and is one of Europe's leading suppliers of human-centric lighting solutions. This is the outline of the presentation. We will first have a short look at how light affects us humans. Second, we will go into why we are using blue block light, and then we will dive into a case study from Østmarka Psychiatric Hospital. And at last, we will have a look at light management systems and the recommended settings. The basic idea of human-centric lighting is to use the benefits of the natural light on the human body. Natural light varies in intensity and color throughout the day, and this is something we want to incorporate into the building to get the same effect of the daylight in the electrical lighting. We have the cool white light in the morning and we have the warm white light in the sunset. In short, that is what we do. I will briefly mention the non-visual effects of light on us humans to put the presentation in the right perspective. Ganglion cells on the retina were discovered in 2002. The ganglion cells contain a protein called melanopsin with a maximum sensitivity curve with a wavelength of approximately 480 nanometers. Blue light is highly prevalent in daylight. Some people are more sensitive to the blue wavelengths than others. A research study indicates that glasses that doesn't let the blue wavelengths through and blocks signals to the ganglion cells can have a positive effect on psychiatric patients with manic episodes. We will have a closer look at this study later in the presentation. Human-centric lighting is light that varies its intensity and color temperature over the course of the day to improve people's circadian rhythm, and we use warm white light in the early morning and late afternoon. During the day, we use cool white light with high intensity. Research shows that the blue block light, with its absence of blue wavelengths, can provide immediate positive effects on people with bipolar disorders. And in new psychiatric hospitals, luminaires with amber light color is used in the treatment of manic depressive patients at night. All these functions with the possibility to change between warm white light and cool white light and also have the amber light is not in two different installations. We have designed products with all functionalities in the same fixture. On the screen you can see two graphs with spectral light distribution. On the left you see a spectral light distribution of a standard 4000 Kelvin LED light source, and to the right you see the spectral power distribution of a luminary with blue block light. And there you can see that we have removed the wavelengths in the blue spectrum. Now we will have a look at the background of why we are using blue block light. The development of blue block light solutions is based on research done by using orange goggle in psychiatric hospitals. Tone Henriksen is a psychiatrist at Valen Hospital and a PhD candidate at the University of Bergen. And her research shows that people with bipolar disorder are sensitive to blue light, which is widespread in daylight. And in her trial, 22 patients with mania got orange goggles from 6 o'clock in the evening to 8 o'clock the next morning for 1 week. And she also used a control group that receives normal shades. After only 3 days, the patient's status was much better. Copying these results using cognitive and conversational therapy would take significantly longer. However, 7 out of the 22 participants would not wear the glasses. And this indicates that the concept is very good, but it is difficult for this target group to use goggles. The best solution would then be to use blue block light as a part of the lighting solution in the building. Here's a quote from a patient in Henriksen's study. I noticed an immediate effect. It didn't take more than 2 to 3 minutes from I put the goggles on until I felt the whole world tone down. This is said by Tuva Marie Martinussen, a bipolar patient, in an interview with the Norwegian Broadcasting Corporation called NRK. I will not go deep into the findings in Henriksen's study, but I will mention that the Young Mania rating scale is used in Henriksen's Blue Block study. Young Mania rating scale is a standardized method to assess and score manic symptoms and bipolar disorders across 11 items ranging from mood and energy levels to speech and disruptive behavior. This slide sums up the results in the Henriksen study. The yellow line shows the BB group and the blue line shows the placebo group. The mean change in the total YMRS score after 7 days of intervention was 14.1 in the BB group as compared to 1.7 in the placebo group, and these results are significant. Henriksen hypothesis a direct influence on mood and cognition. The rapid reduction in the YMRS item scores related to activation in the BB group gives us reason to state the hypothesis that the anti-manic effect seen during BB treatment is due to silencing the signals to the ganglion cells. A very exciting news is the international recognition Henriksen's study has received, and the fact that it's become a recommendation through a review study that's been published in the medical journal Bipolar Disorder recently. The following is recommended in the review study. While literal darkness is difficult to administer, the feasibility of using blue block lenses has been demonstrated in the Henriksen trial, and they are now being increasingly used in our own inpatient units for patients admitted with acute mania. Alternatively, a dynamic LED lighting system can be installed in a hospital unit and be used to create a blue depleted evening light environment similar to a virtual darkness. Indeed, a RCT to test the effectiveness of such an evening blue depleted light environment is underway in a psychiatric emergency ward. The emergency ward, which is referred to, is Østmarka Psychiatric Hospital in Norway, which we will have a closer look on later. Håvard Kalstad at Østmarka Psychiatric Hospital says the following in an interview with the Norwegian Broadcasting Corporation. Treatment with light and darkness affects the patient's circadian rhythm and has been shown to be effective, simple and fast acting, and not at least it's drug-free. This is a quote from Kallestad, and he is also one of the 27 authors of the review study mentioned in the previous slide. And now we are introducing Østmarka case study. We are also supplying the same BBL solutions at the Kalmar Psychiatric Hospital in Sweden and at Sandviken Psychiatric Hospital in Bergen in Norway. Østmarka Psychiatric Hospital is part of Trondheim University Hospital, St. Olavs. In November 2017, the patients and the staff moved into the new premises. And the building is built with 2 identical wings, one wing with blue block light and one wing with standard static white LED light. This is done to be able to do the planned study where they compare the patients living under the different conditions. The result of the research is planned to be published soon, and we look forward to see the results. The hospital's two departments, the one with standard lighting and the one with blue block light, enables the researchers to compare patients that are exposed to blue block light with the patients that are not. The objective is to assist the circadian entrainment of the patients and thereby mitigate their symptoms, in addition to Henriksen's findings of the direct influence on mood and cognition. From 6:30 in the afternoon to 8 o'clock the next morning, the patients will only be exposed to orange light containing no blue wavelengths. The aim is to shorten the patient's stay at the hospital. One wing is sealed off with orange light. The staff room has its own setting and it's removed from the orange light cycle. And the doctors can prescribe blue block light to individual rooms and bathrooms. At Østmarka, during daytime, the color of the white light is fixed at 3000 kelvins, and in the evening at 1830, the light automatically turns orange, and this light is uncontrollable by the patient until 8 o'clock the next morning. The patient can dim and turn off the light, but they cannot change the color. Here we see the patient room user interface. The first bottom is the blinds up and down, and this is temperature sensor. And at the bottom we have the light switch. The patient can turn the light on and off, and they can have it in portions. 60% light or 30% light. The patient cannot change the color temperature or the color of the light, but the patient have a certain control over their light settings. All areas in the blue blocked department is equipped with the blue block light. This goes for corridors, living rooms, and also the patient bathrooms. Patients can voluntarily expose themselves to high light doses during the day to enhance mood and concentration and to shift their daily rhythm forward. This is the daylight corner, and the illuminance level is 8000 lux vertical, 45 centimeters from the wall. And these fittings are fixed at 6500 Ks during daytime. This area is in connection with the canteen. As mentioned, the light in the staff room is set to standard office lighting, and as you can see on the picture to the left, they have orange filters on the windows and doors to the corridor, and this is to avoid white light to spread into the areas where the patient move. At 1830 in the evening, the window filter goes automatically down outside the windows to block the blue wavelengths of the natural light out. On the right hand side, you can see the test results from the different filters that were into consideration. And the gray line is the chosen filter from Lumar. It's done several studies on the psychiatric hospital at Østmarka, and one of them was a study on 12 healthy students that lived 2 times 5 days in each department at Østmarka. 5 days under normal light and 5 days under blue block light. Among other things, the melatonin levels was measured every day, and the result? Blue block light leads to an earlier release of melatonin compared to standard lighting. This may lead to favorable circadian shifts for psychiatric patients. The staff of the hospital is also pleased with the lighting installation. This is a quote from Øyvind, who is a psychiatric nurse at the hospital, and he says, "It hasn't taken long to get used to the new light. The patients are also very pleased." Key for a blue block light installation is a well-functionable light management system. Now we will look at some recommended settings for the LMS system. Blue block light solutions require sophisticated light management systems. Such systems goes beyond standard dimming functionality, and they contain advanced light cycles and user rights. These systems they can be based on DALI or KNX. Given the complexity of the systems, the user rights and the interfaces needs to be carefully analyzed and designed. Glamox, among others, offer light management systems for blue block light solutions and can tailor the solutions for your project. Now we will look at some recommended settings and rights for the LMS system. The administrator is usually the hospital electrotechnical department, and they do programming of the light cycle, configuration of the user interface, and the doctor contributes with the input to the programming of the cycle. The staff can start/turn off cycle per room and turn on emergency light, which can be 100% light with white light in case of emergency. And they do this from the screen in the staff. As we saw earlier, the patient can control the amount of light in his room, and he can turn the light on and off, but he cannot change the color of the light. To sum it up, research shows that blue block light can provide immediate positive effects on people with bipolar disorders. A review study published in the medical journal Bipolar Disorder recommends a dynamic LED light system that can be installed in a hospital unit and to be used to create a blue depleted evening light environment similar to a virtual darkness. Blue block light is installed at Østmarka Psychiatric Hospital, and from 6:30 in the afternoon until 8 o'clock the next morning, the patients will only be exposed to orange light with no blue wavelengths. Blue block lighting solutions require sophisticated LMS systems. If you have any questions related to the presentation, do not hesitate to get in touch with me or Glamox in your local market. Here you can see my contact details. And thank you for listening, and I hope to see you again soon.